We'd like to welcome everybody to our systems facing meeting for this month. We've got a great topic lined up for today. So a couple quick announcements just as we get started. There will be no usual July meeting for our systems facing track. We'll send out more information in the general announcements later that kind of details this, but instead what we're going to try to do is find an opportunity to do a little social activity at PERC 22 for anybody who is in attendance. Just an opportunity to kind of get together, say hi, rub shoulders, for those in attendance. But PERC tends to line up a little bit too close to our normal meeting. So instead of trying to double down in that month, this is what we'll do this month. We're also working on some interesting plans for August. We're not quite ready to send all those out, but do keep your eye open for the August plans because we're pretty excited about what we're working on for the coming plans. So with that in mind, we've got a great topic today on JupyterHub at Ncar. And this is a case study for a notebook-centric analysis platform around the Jupyter ecosystem. We've got Jared Baker here to present on that. And I kind of asked Jared if he wouldn't mind giving a little introduction to himself and also if he wouldn't mind guiding everybody on how he'd like to take questions and answers through the session. But turn the time over to Jared.
Thanks, Brian. Just let me share my screen real quick. Grab chat as well. Okay, I just asked that folks can see the screen properly. Yes.
Yep.
Great. So this is going to be a presentation about JupyterHub at Ncar. It's a case for a notebook-centric analysis platform, basically, and moving to the Jupyter ecosystem for older tools. So I'm a senior systems engineer at Ncar, and we do a lot of climate science, meteorology, fire prediction, stuff like that. But so we'll go into it. Firstly, Ncar is a NSF center, and so this work is all sponsored by them. But a lot of opinions may reflect my own, and certainly do as far as open source applications go. And just a quick shout out. Wouldn't have been a whole lot of effort to not mention Eric, Brian, Emma, and Kevin. These are some of the colleagues I work with, and they help me maintain JupyterHub and make it as successful as it is today. But anyways, going back to myself, I've been heavily involved in JupyterHub, at least at Ncar for a few years now. So this vision is going to represent what I feel about JupyterHub and why I think it's valuable. So if you have any questions along the way, feel free to ask them. If you want to save them to the end, that's fine. I'm on a number of Slack channels, and my email will be at the end of the deck, but I'm kind of an open book. Whenever you have questions, feel free to find me wherever I may be living or just lurking in the shadows. I'm going to give you a little bit of background. So Ncar is sponsored by the National Science Foundation and is managed by a university corporation for atmospheric research. Basically what that means is that Ncar is managed by a set of universities that specialize in programs with atmospheric research. I think the last count was somewhere above 60. So it's quite a broad range of universities that support Ncar. And so what is Ncar? It's a world-class research center leading, promoting, and facilitating innovation in atmospheric and related Earth and Sun system sciences. So basically, we do a lot of climate, we do weather, we do hurricane forecasting, all sorts of things related to Earth system science. And so what is our mission? Basically to provide and enhance capabilities across the scientific community in favor for a broad user community. So in general, I work for a lab that's known as the Computational Information Systems Laboratory. And we have our own little dedicated mission, and that's to basically support and advance Earth system sciences by providing world-class computing environments, data services, and research in computational science itself. So each year we provide a number of resource services, consulting to more than 1,500 users at 500 different universities and research institutions across the globe. And we are used by tens of thousands of researchers worldwide. We have data that we've disseminated out into the cloud for atmospheric research as well. And so we distribute a lot of information around the world. To get a better understanding of why we have JupyterHub configured the way we do, we need to talk a little bit about the resources that exist at Ncar, and we won't spend a lot of time on them, but just going to get a collection of what all they are and their breadth a little bit. So we'll start by Cheyenne. Cheyenne's our current flagship computer, soon to be replaced. It's just over 5 years now. It's 145,000 processors on 4,032 nodes. It's got an enhanced 90 partial hypercube InfiniBand interconnect, 6 login nodes, compile nodes, and 4 general support nodes. We run PBS Professional. I know a lot of universities out there are big Slurm sites, but we are using PBS on all of our systems here. And then we have Casper, and Casper is a code name for our data analysis and visualization compute cluster. And one can think of this as everything that doesn't fit in the supercomputer class systems. So this includes whether it's vendor peaks at technologies or one-off computing devices such as GPUs when they first came out. Also high memory nodes. So we have nodes that have 1.5 terabyte of memory that are used for large database workloads. But Casper is one that is targeted really at as our data analysis and visualization, and is probably our most used JupyterHub platform at the site. So what makes it unique is that we offer a remote desktop, longer running jobs, multiple networks. So we have 100 gig Ethernet that is public facing network. So you can SSH to your batch node from anywhere in the world, no VPN required. And then we also have InfiniBand network on this that is around HDR, especially designed for the GPU elements of the system. So it's expandable, it's very dynamic, currently runs on CentOS 7, PBS Professional as well. But this is where I'd say 85 to 90% of our JupyterHub users actually live. So then we have a wide array of storage that can be attached basically to all of our systems. We have what's called Glade, 38 petabyte IBM Spectrum scale on DDN hardware. It's both InfiniBand and 100 gig Ethernet connected into our Cheyenne system that provides basic Scratch project and workspaces for the user community. And then we have our large campaign store, which is 90 petabytes, and that's on DDN 18Ks, I believe, and that's 100 gig E connected everywhere, no InfiniBand. We'll explain why that is in a minute. But this provides medium and long-term storage. So when we talk about medium to long-term storage at Ncar, that's anywhere from probably the 3, 5, 10-year period. Anything longer would eventually move over to the Quasar system if it's deemed appropriate. So this is an indefinite lifetime system, but it's curated data. There is a disaster recovery option, but it's available only on a per project basis. It's 100 gig E connected at the front end, and it's both Spectrum scale, tiering down to the Spectrum archive for tape. So that's our indefinite archive. A lot of data that ends up here is experimental data that's been collected, whether it be ice core samples, airplane metrics that have been collected on board, stuff that you can't ever get back in the future. Then we have Glade U. This is a specially designed file system. This is basically home and applications and other small file high access trees. So if we have a set of container images that are hit very often, this is where those live. And it's also an IBM Spectrum scale appliance on DDN. And then we have Stratus, and Stratus is kind of a unique one in our environment, but it's gaining popularity here and there. It's a 5 petabyte object storage system, and basically it's an expanded proof of concept for testing S3 with different technologies at NCAR. So we're working on that with a number of our scientific groups as well. And this is long-term storage as well, but something that is faster retrieved than what tape offers. And this is all multiple 10 gig connections into the various clusters. And then what we have upcoming in the future, pending supply chain and everything going on, is our new upcoming supercomputer Duratio. It's kind of an interesting system. It's an HP Cray EX platform, so it's more than double the processor count as far as cores. But one of the first things that, from an NCAR perspective, that's unique is that we will have a moderately heavy use of GPUs in the system versus our systems in the past. And the other thing is we will be moving away from the InfiniBand technology to the Slingshot 11 interconnect. And this has a lot to do with its Ethernet capability and performance that is suggested on it, and making our systems a little bit more ubiquitous as far as network traffic. And this will run SLES15 and Cray OS together, and we'll be using PBS Professional as well. Interestingly enough, it's also going to be paired with a ClusterStor E1000, and that's going to provide us with 60 petabytes of Lustre scratch space, which is interesting because we've been an IBM Spectrum Scale user for quite some time now, so well over a decade. And then we have the glue that sticks all of these resources together, which ultimately JupyterHub is sitting on top of and making it usable for all our researchers. We've called this the Bifrost Network, kind of a play on names, since networks never really touch end users. They just know that things work. So this is a 200 gigabit Ethernet core. It revolves around the Mellanox SN3700 with Cumulus Linux. We intended to be an isolated system when we bought this, so Mellanox and Cumulus were independent vendors at that point, and right up until our deployment, then they were consumed into one entity. But ultimately designed to give us a fast path everywhere to any compute resource within the NCAR ecosystem. So with that, why did NCAR choose the Jupyter ecosystem, and why do we want to work on notebooks? Well, NCAR's got some very, call them ancient tools in the computing space. Many of you probably have users that use tools like NCL or such that are independent binaries distributed for doing various things related to earth sciences. So they've started migrating a lot of that utility into Python projects, making them easier to program against other codes or move into other frameworks much more easily. So we have Project Pythia that is doing a vast amount of that, but also just Python's becoming a much more used language across the globe itself. So it's lowering that bar to entry by making this easier to run. We have several groups that are working on things to run flagship applications like wrf or CSM on things like Raspberry Pis or Raspberry Pi clusters even. And so this is where we're headed, to make Python kind of a core unit of analysis platforms for our community. So we got various different projects out there. GeoCAT represents a visualization and analysis package around the geoscientific space. Dask is a really popular one here at NCAR. This has to do with distributed computing, but less in the sense of MPI workloads and such. And then we use fundamental tools like XAR and Xarray to do data chunking on the file system or in memory. So these are all tools that we're bringing together as part of our JupyterHub implementation. So again, why did we choose it? We have a desire to work within a Python ecosystem, leveraging any kind of virtual environment tooling you want. This includes PyM, Conda, pipenv, virtualenv, whatever you want. Also, if you want to throw those in containers, right, it should be easy enough to do. And then our research community really likes the concept of notebook-based tooling, where analysis can really be annotated in line and visualized in one cohesive document. So the notebook-based computing is really where our researchers are wanting to live, to show their results and to express their data. It also offers a lower barrier to access for end users. And this is another one of the principal reasons why we're doing JupyterHub, is that this should all be able to be used from any platform, whether it be a workstation, laptop, tablet, or even a mobile phone, right? We want people to be able to have those lunchtime conversations and show those notebooks with their data. We want to make it easy to walk around and have a collaborative mode of computing with people. So we want to lower that barrier, less CLI if possible, especially when we're visualizing data. And then we want to make sure that we maintain state between devices. So if you move from your laptop to your workstation, right, you should be able to pick up your computation just like you would do in a terminal with Screen or Tmux. That's one of our ultimate requirements, is that, continuous computing, right? Be able to move somewhere and then pick up your task wherever you get. And then it should be extensible. And this includes, providing additional features, quickly iterate, write plugins for things, and using a Python open source ecosystem really helps facilitate that. So it's about bridging some of that gap between our researchers and our engineers. So what is JupyterHub? I'm sure many of you have heard of it before, but it's fundamentally a web application that's focused on providing a multi-user ecosystem for notebook-style computing. And honestly, it's easy to deploy on laptops, servers, clouds, clusters, and supercomputers. It's not really as tedious as people might think. There are examples from how to do 0 to JupyterHub for different environments. So you can use it, like I said, on your laptop. You could use it in Kubernetes on a managed cluster out in the cloud, or you can use it on a supercomputer with batch spawners like PBS or Slurm. So the hub consists of 3 primary components, right? We have a hub application that's kind of the brain. We have a proxy that is basically the traffic warden. And then we have a database, which is a keeper of state. And so the hub is, basically built on top of Python, JavaScript, jQuery, Jinja, and HTML for the most part. A little bit of CSS in there for look and feel, but the cores are listed there. And then the database, SQLite 3, MariaDB or MySQL, or Postgres are options. And then the proxy, out of the box, you can use a configurable HTTP proxy or something known as traffic if you want to become more scalable, cloud ready, cloud native. Again, the main application here, so the hub application is what we're talking about. It's written in Python, and the front end uses more traditional web technologies, but it's fundamentally in charge of authentication, management of servers, application state, and proxy configuration. And the important thing for Ncar will be the servers are all started via these spawners, and spawners are units that start, poll, stop running single user servers that run any sort of Jupyter Notebook or JupyterLab sessions on whatever resources you have defined. What's nice about JupyterHub is it's got a web interface that can be themed, customized, basically to give your site the look and feel if it wanted. Maybe make it a little more user-friendly for your user community, like we've done at our site. So just a little bit of watch the paper cuts that your user community has. They can likely be tweaked to your heart's desire. And then you have a proxy. Now, out of the box, like I mentioned, there are 2 proxy implementations that can be used. Configurable HTTP proxy. This is a single process Node.js application. Works fairly well. We use it at Ncar. One of the problems, though, is it's not as, I guess, resilient in a number of ways that we would like it to be, but our systems are fairly resilient in that sense. So we do use it, but it is fully in memory. And so if the process ever stops for any point in time, you would lose that state. And the only way to get that state back is to restart the hub from getting a clean state through the database. So if you're more inclined, you can configure traffic pretty easily. It's written in Go, and it's specifically designed for doing service-like discovery and reverse proxying, load balancing. But you can keep state in various ways, including a single node TOML files. You can use key value store or console as well. One thing that we usually don't talk about too often, though, is there's an additional proxy that a lot of folks tend to employ, and that is just a front-end reverse proxy. So we use Nginx as our preferred choice, and this does, our open or our SSL termination at the first layer, and kind of provides our gateway. So it also does some security layers for our site as well. So we do have Nginx that sits in front of everything. And then there's the database, right? This is the third component, and this is ultimately the state keeper. So the hub application writes state to database, and then if the hub application fails, needs to be restarted for any point in time. Whatever it is, the hub needs to be able to read from the database and recover the state so that users can get back to working without their sessions being interrupted, right? You need to keep their compute going, whether or not the top level application hangs up or not. It's very important to properly update the database when doing upgrades. Their schema can change from time to time, but it's usually a fairly painless update. Like I said, we usually do this in downtime periods anyway. So if we lose the database for any particular reason, well, that's okay. But if you're going to be modifying and keeping the service up for lengthy periods of time, always do backups. And the backup is completely dependent on your database implementation. We use SQLite as the database. It's simple enough, but it's also sitting on top of our Glade U file system, which is very performant for small writes, reads, things like that. So it works fine. It's well distributed. But we have used Postgres in the past, and we may move to it completely in the future, depending on what goes on with our application store in the future. The Postgres database may just make more sense long term. So I wanted to give everybody a little bit of walkthrough through our site. So this is the main page if you were to go to jupyterhub.hpc.ucar.edu. You're greeted with two different options, very simple. Basically, you have a production instance and a development or nightly instance. And that's exactly what it is. Production is stable. We do quarterly updates, basically, or security updates as necessary. It's designed to basically be running, always available, anything like that. The development or nightly instance isn't really nightly, but we like to give the notion that it is nightly. So we reserve it to be interrupted on Tuesday, Thursdays. Realistically, that doesn't happen very often, but if we have a sprint or something that we're working on, right, Tuesdays and Thursdays are the dedicated days to working on that particular instance. It's also the instance that we have users use to do requests for features, anything like that. We can integrate and test with them real time. So we might have Zoom calls or Google Meets just like this, and work through their issues by tweaking our hub environment right on the fly for them. So they really appreciate that. It lets us work through a number of things. It's also nice that our users have access to both, right? So just in case one is acting funny or one goes down for a specific reason, they can always access the other one. They're completely independent, so we really enjoy them like that. And our user community has really appreciated having two specific instances that we can iterate on. So we got a small tweak of a sign-in page, right? agree to terms and services, right? That's in the template if you would like. But very feature. We don't like to tweak our hub environment too much to have users have an uneasy feeling or a different feeling from other Jupyter hubs. So we keep our look and feel very consistent, but keep it in line with Ncar's web publishing rules as well. So you log in, you get passed to the home screen. Now this will look a little bit differently with the inclusion of what are known as named servers. We've decided to put everything in a single table rather than have a large set of buttons at the top. So we've moved everything down to a single table and basically redone the table because we'll see why we have multiple resources that we are able to use. So we want to remind users what resource corresponds to each server instance that they've been able to start. They're also warned that if this is a development instance, right, it's noted at the top. And basically, if, Tuesdays and Thursdays, if they have issues with that, well, we say it's Tuesday and Thursday, go use stable, right? And there's a link to that. One thing you'll also notice up here, and we'll see in another slide, is that we've added an Ncar menu up here as well. And that's basically to get our help documentation as close as possible to the users, right? We don't want to have them to open up Google to try to find as much documentation. Although Google is very friendly, if it's easy and discoverable, users are more likely to read the help when they can find it easily. So when you add named servers, maybe you're at a conference and you want to have one that's completely different from your running session where you're actually doing research, named servers are a great option. So you can add various ones in our environment, right? The one pitfall that we have, it's been an open bug for a while, is making sure that users don't include spaces in the name of their servers because it doesn't get properly escaped in the web app, and therefore spaces break URL entries. So that's one thing that we have fixed on our end of it, is that spaces are basically translated into underscores at this point. So our user community has asked us very kindly to keep them from doing silly things like that, because there is no error associated that's well explainable when that happens. So when you go to spawn, you're greeted with a first level form. By default, we go to our Casper login session, and you can launch that. No options required, anything like that. It's just point and click, go, right? Get a session. This will give you basically two cores and 4 gigs of RAM to play with. So a lot of people use this just as, hey, I want a terminal, or I want a simple notebook interface, or I want to control my DAS cluster from here. They can do all that through here pretty easily. But what about the users that need more control, right? So we also have options like create a custom batch job. So select what type of GPU you want, select how many GPUs you want, number of cores, number of nodes, how much memory, right? That's all integrated within the form on the next level. So here's an example of our form. It's fairly straightforward. It's got fairly minimal defaults to it, but go to your heart's content on things. They have proper limits in that correspond with our limits for the workload manager or the physical devices themselves. So this is really nice for us. We feel it's very clean. We don't like to offer too many different types of options because, like I said, one of the desires is to make sure this platform works on mobile devices as well, right? So getting outrageous forms in place and filling that out on mobile is complicated, but we also want to be as flexible as possible for different users. And you will get different forms based on the different PBS instances you want as well. And this is configurable with what you'll see later. This is not limited just to like PBS batch systems either. So again, here's our little help menu. Again, go back to the portal, any online documentation that you need to find, terms and conditions, right? This is just very, we wish it was in the default hub where you could just put this in the configuration file with some links, but it's not. So, but it's fairly simple to add as far as things go. This is an admin menu for people that are systems facing folks. You're likely to be one of the admin if you're managing this. Things that are available are selecting users, right? Edit user, add them to different groups, such. And these are all settings that are contained within JupyterHub, right? These aren't altering like Unix groups or anything like that. They're JupyterHub groups. And that takes a little bit of an idea to get your head wrapped around that groups in JupyterHub are not the same as your Unix groups. And there's good reasons for that. So again, this is the admin menu. I've been very tempted to hide the shutdown hub menu or button. It is just, it's a danger button that I don't want anybody ever clicking. If you're clicking it, you don't know what you're doing at our site. So we might get rid of that in the near future. One thing that is really nice is that, at least on the new versions of JupyterHub, is the search users box. For anybody that remembers older 1 or earlier days, basically your users would just get paginated and you'd have to go searching. But if you tried to search by last activity or such, it wasn't exactly in what you would have thought would have been the proper order. At least it wasn't for me. So this search users, go find the user you're looking for, and you can, start their servers, stop their servers, whatever you want. You can see the configuration of their server session, all that. So the admin menu is extremely useful in its upcoming one. This was just moved from whatever they had before into a full React app at this point. So it's quite nice. And then you log in and you're greeted. We have JupyterLab is basically configured as our default. We've been fairly minimal on the number of kernel tiles that we've been producing, mainly because these are tiles and they take up a lot of space on this menu. So we've been only doing our most used, but we would like to project more of our environments or kernels that we offer, like through modules or something like that. But it just feels space constrained if we were to add too many. So we keep it to our most used ones here. Let's see, again, another Ncar menu up in the lab here. Go to our Project Pythia, Ncar GeoCAT, wrf-python, any Ncar help, go back to your servers page and the JupyterHub portal itself. Right, these are all quick links just to make the user experience more cohesive for them, right?
Hey, Jared. So maybe a question, and you can tell me whether this is a good time for it or not, but do you have, usage cases that might be seen as maybe like a classroom or a lecture or a training series where you have an instructor that might come to you and is going to have a number of other people that are going to connect in, and this instructor then has kind of a unique set of, environment requirements that they want their instance to have, that they want then all these people in that session to have, without basically ask you to help prepare this versus require each of the participants to run a bunch of extra commands to load the extra modules in?
Yep. Yeah. So we offer that as kind of a naive approach, but it's progressing. So I would work with researchers directly in preparing for workshops, conferences, whatever they wanted, to create kernels that they would use for basically in a shared space, right? And then those tiles would show up here. Now they would be generally available for anybody, right? There's no reason to restrict them any further, because I don't want to keep a book of who's attending the conferences either and work that model in, right? Just make it available. We're an open science site, have at it. So we would put kernels in there. Now I've since moved off our kernel generation off to our software consulting group, and they are more in charge of that. But in a minute here, I'll describe what we've got set up on our future spawners that might enable more of a customization, so to speak, on maybe if we need a particular type of environment for the workshop, something that is configured differently or requires maybe container usage that's not our standard JupyterLab instance, for example, right? So we have an upcoming way. We haven't actually done it yet, but we've gotten further on our JupyterHub implementation of our custom spawner, that should be fairly easy to do and tweak, and also add dynamically, which is nice, right? Not interrupting the hub, but basically adding some information to a YAML file and off you go, which I think is really probably the proper way to go, right? You have to have a little bit of backend knowledge on, what's being launched, but other than that, it'd be fairly easy to add like a workshop spawner if it were an option. And I think that's probably the proper direction to go. And then you can take it out if it's that much of a customization, right? I mean, typically we'll start with a kernel, but for example, if we do something very specific with GPUs, it requires, them to be inside of some sort of NVIDIA container, we might want to just go ahead and do that for them and not make them try to jump through a number of different loops, right? So does that answer your question?
Yes, thanks.
So, okay, now that we've launched an instance, what does it look like from our home page? And this is our small edits, right? Not too much effort was put into place once you know what's going on, but we have our default server here. The resource was a Casper login, and we haven't got the time remaining down yet because that's not actually something that's calculated in our spawner yet, but is intended to be so that users can see that time remaining on their sessions, right? But then very easy, stop button. So they get some information about which session belongs to which, because that was one of our, I guess, complaints, is that while they had named servers, it didn't really tell them anything. So they would name their server something like Casper or Cheyenne, but that was just a logical name and didn't really represent their workflow. It was identifying a resource. And that's not really what we wanted our named servers to mean. We wanted them to be something for their workflow. So adding this resource column that told them their resource was extremely useful to the end user community. So our overall hub configuration, just a few side notes, is that we run our hub application and our proxy application in different system D units. Keeping that proxy up is extremely important, right? If the hub goes away, it doesn't mean your sessions that are running for your users goes away. It means that you can't start new sessions and you can't terminate old ones, but you can still use the ones that are up and running. So keeping that proxy up is important. The configuration file has an option that's required to keep a proxy running if you want. We basically just tell ours not to start a proxy at all and to not worry about it. But we really want, I guess basically we really tell it not to start and not to ever tear it down. But we have them in system D units that are different because system D will be extremely helpful here and killing off your processes when you try to restart the hub. So run them separately. It's not a overbearing task, but it makes a lot of sense and it eases pain quite easily. And then we've created a custom spawner that allows forms to dynamically be created so that a user can select whatever system they want with flexible options. And then get to the help documentation in as few clicks as possible. And then make sure our reverse proxy can handle larger than normal payloads. The first time I saw a gigabyte Jupyter notebook, I was kind of beside myself. That's a web application. Why is it a gigabyte? But remember that Jupyter notebooks also store images and such, right? So when you have large plots or large color maps in long notebooks, they get quite big. So your reverse proxy needs to be able to handle such cases. And then the last thing that we haven't really done, it's on the to-do list at some point. It's kind of like free time, but when we're getting HTTP error codes, basically we want to configure our proxy to render a page that says, hey, if you made it here, it's an error. Here's how to open a ticket. Here's what information to include, right? Make it easy for the end users to support or to submit a proper bug report for you. Make your life easy by giving them the proper information on how to do such. So like I said, we've written a custom spawner implementation that basically subclasses what's known as wrap spawner. And that just allows you to have basically, if you want to call them child spawners or nested spawners, whichever one you want. So tentatively, we've named our site spawner because we had an idea that we were going to span sites at this point. It's kind of evolved. One of my colleagues, Eric, wanted to do meta spawner. Unfortunately, that was right about the time Facebook came up with the name Meta, and we all got a bad taste in our mouth with that. So meta spawner is out. So looking for names, if anybody has any good ideas, we're more than open to name our spawner something useful. But basically our site spawner sits on or is above the batch spawner and SSH spawners we use, and we can implement other ones as well. So in a couple months, we'll be implementing a cube spawner, basically to test cloud bursting that is an alternative bursting mode to like PBS cloud bursting done through our workload manager there. But this all takes inspiration from an older archive project that was at CU, basically an options form, and an options form basically got wrapped into JupyterHub as a native unit quite a while ago. But I remember when JupyterHub had basically no options form, or not an easy options form to do, and we took a lot of our uses from that. I believe it was JupyterHub option spawner. It's been archived and I couldn't find the GitHub link anymore, but if anybody wants to know more about it, feel free to ping me. So what does our site spawner basically, how do you configure site spawner, right? We've decided that, well, we being me at this point, decided that a YAML file that could be read for every invocation of a session should be done. So we've created this YAML file. It looks onerous, but it's really no worse than how you would have a JupyterHub configuration in general. It has a lot of the same key values that you would have to put in there as dictionaries inside of the JupyterHub config anyway. So it's just, to me, it's a little bit more readable in this regard, a little bit more straightforward, and just allows it to be a little bit more dynamic because it has to be read every time. So it's somewhat like using a machinery to implement the configuration and the subunits as just a basic configuration file that's extended. So you can see that we have our CR batch, which is our name. We label it Casper PBS batch, which is what the user will see. Enabled is true. Note if you want to put this as going in for maintenance soon, or you'll see another instance where we have enable is false. And the note is because it's a future selection, right? The equipment hasn't arrived yet, but it's on the way. And then you configure the spawner. So here we have the batch spawner, PBS spawner, and we go through the standard configs that you would have in a dictionary there. Sorry about that. And then we have our batch script. So this is where I was, as Brian mentioned, how can we tweak our environment to support that, right? Well, if it's going to submit to PBS, we write a new configuration and we can call it whatever we want, conference or workshop, and label it as such. Users can start that and we can create a custom PBS script that runs that. So if we have no options or anything, or need to select specific queues, we can do that all in here without even restarting the hub, right? We can just read it in. There is a caveat to that you need to be very careful because it is a YAML file and broken YAML files don't read well into Python. So there's a little bit of a be careful and do an atomic update after you validated a YAML file. But I found that this is very nice. It was very straightforward. After our last outage, I kind of walked away and made one of my colleagues start up JupyterHub on their own and enable the services and kind of do self-discovery. And they all claimed it was extremely easy to figure out what was going on and why things were either enabled or disabled. So they did that without me having to tell them how to do something or even drop a ton of breadcrumbs in places. So that was extremely nice to hear. Again, and then so you go down and these resource options are all paired with the PBS script above. So you have something like partition or account, nodes, right? These are all just basically resources that you can select as part of the job submission. In case of our Casper PBS, we add this suffix onto the queue or reservation because this is being submitted from a non-Casper PBS node, basically. This is running on an external server, and in PBS, doing an @Casper PBS gives you a destination to look or to submit to. It's been extended so that we can use commands. If you want to run a command to populate a list of queues or reservations that are available to users, you can do that. And then we've also got some functionality if you want to implement a Python function inside your JupyterHub config file, you can do that as well. I prefer the Unix command because I can run it externally and not have to worry too much about it or throwing an assertion anywhere. It may just give me a blank list at the end of the day, right? So that's what I prefer. Sorry, I'm back, but you know, it supports the use of like min, max, anything like that. Wow, we really need to go on. So that all gets rendered into the form, provides limits. Then we have our deratio one. This one's false, future selection, resource options. It doesn't exist yet, so it's false. So enable equals false is good for anything if you want to do maintenance mode, or like I said, the resource simply doesn't exist yet. Pros and cons of doing a YAML file. Pros, easily added to, integrated, and it's instantaneous feedback. We can easily enable, disable resources, minimal intervention, and it's fairly trivial for system administrators to understand what's going on. Cons, YAML files can be sensitive. A broken one ultimately renders an error for a web page instead of giving a form, and that's something that we need to address. But and it requires additional configuration outside of your base configuration file. And I'm sure there's something else, but not off the top of my head. Those are the two that have ultimately bitten me or made me feel uneasy. Just general housekeeping for users, cleaning up after them. So culling idle kernels when they're not being used on their servers, culling idle servers. This is done from the hub side. So if a user walks off for the weekend, right, clean up their stuff, because if it's not doing anything, it's still blocking resources from other users. And then enforcing wall time. This is basically workload manager guillotine. Just, you know, that's the end of the job. You want to go, keep going, you know, submit. You can submit a ticket to get extended wall time from an admin perspective, but likely not going to occur. Prefer you to keep state. And since a lot of Jupyter notebooks can save active state, the problem is they lose their in-memory runtime, right? So that can be a problem. We do use ephemeral runtime directories to make sure that we clean up any sort of kernel files or IPC socket files that are left around as well. Metrics. Metrics on the hub are important because people like to understand what's going on with the unit, but the different metrics are important to different sets of people, right? So our management wants to know how many active users, you know, what kind of information are they gaining from it? Is it used for workshops, and if it's impacting other users? So this is the one we're most concerned with, but for system engineers, we like to use metrics on how many sessions are running, how many servers per user, are we hitting a high watermark with our resources, stuff like that. And software consultants want to know what software is being used, like which kernels, which packages, everything like that. But for the management, we've started running a bunch of our metrics into an influx, or was going into an InfluxDB server. Now it's going into Timescale. But simple things for our management to ascertain how many users we have going on at any point in time. So what's next? I don't know if many of you know, the Silk UI server basically is a user-based workflow management tool that allows them to create a graph of jobs that need to be done, and we'll do restarts, resubmissions based on failure modes. And so visualizing the graph and submission through this is our next step. Silk is used very predominantly in atmospheric and meteorology areas, but their new user interface is being implemented as a Jupyter style application. So we're going through there. But one of the things that's kind of kept us until the JupyterHub 2.0 is that we've been looking at integrating operational accounts. And so the RBAC model became really important to us because we have shared user accounts that are necessitating this. So the RBAC was a way that we believe that we will be able to integrate the Silk workflow manager into Jupyter as just a nice web portal.
Jared, there's
Yep.
a question that got thrown out in chat that says asking where the hub itself is actually run. You know, you might have covered this, but is it on a node attached to the system, separate hardware?
It's on one of those support nodes attached to Cheyenne. Basically, that gives us an InfiniBand link into that system, and we also have a 100 gig E connection off of that. Not that you need 100 gig E to that, but we've kind of based everything around that Bifrost network. So if it has a connection onto Bifrost and into our InfiniBand, it's good to go. In the future, when Duratio gets here, anything on our Bifrost network will be good to go for any of our systems. Right, we'll have routes from anywhere on Bifrost into any cluster. So it does sit on a node, but it basically runs in a container, so to speak. So it's on a shared system, but there aren't many other things going on that support node as well. So going on. So the next thing, I know we're running low on time here, but people love the aspect of shared and collaborative documents, right? So Google Docs, HackMD, CodeMD, whatever you want to call your collaborated tool of choice in real time, Jupyter notebooks want to be there. Well, JupyterLab 3.1 has capability to do real-time collaboration. Great. Requires a flag on startup. Okay, not a big deal. But includes a token, but that token is based on the lab session, not on the JupyterHub session. So you may not have the proper proxy and authentication to actually get in there. So we're exploring how real-time collaboration could be implemented in the multi-user framework as well. And that's not the same as a shared user use case, right? It's collaborative, not a single user, but multiple users on the same thing. And another thing, sharing code with colleagues, reproducibility things. So binder hub. How do we do that for HPC in an authenticated manner? You know, how do we build those images from containers and GitHub repos, right? How do we do all of that and get it paired into our ecosystem for starting a PBS job with Dask and everything else running in the background, right? That's kind of what we're looking at. So one of my colleagues, Kevin, has started to develop something that offers binder-like capability on HPC. So just a real quick recap of our future desires: Silk UE servers for shared user accounts and using role-based access controls, real-time collaboration, repeatability and examples dissemination via utilities like Binder, and then on the security front, end-to-end encryption is on the list. We have the ends encrypted, but not all the way through the pipe. So if you're sniffing in the right spot, you can probably get something, but our user community is generally not looking to do that, so to speak. So it is on the list of to-dos, but not quite there yet. And then in JupyterLab, we want to offer more batch job information. You shouldn't have to open a terminal to get your job ID or your resource usage. So we're going to work on basically an extension with a little pop-up, give you your job information, stuff like that. File system code information, you know, maybe have some like tachometer style charts or whatnot for understanding how much capacity, how many inodes you've used on various file systems. License usage. So we use a lot of MATLAB and a lot of IDL, and a lot of times we hit those limits. So self-servicing how many licenses are available is something that we'd like to have right in the portal itself. And then more scalable view for kernel options, right? We talked about the tiles. We might like more of a table classification. So that with like a search box and metadata that we can attach to showing those kernels, so that users can search out what they want to do versus just tagging like kernels and such. So wrapping up with, full 2 minutes left. if you have questions now, perfect, ask them away. If you're a little shyer, you're more than welcome to email me or find me on one of the Slack channels, part of the RMAC, HPC SysPros, or the Kirk channel. So again, more than welcome to reach out and ask me questions. If I'm at conferences, I'll likely be hanging out in the Jupyter or interactive computing rooms. So feel free to find me at any conferences I may be at. But yeah, if you just want to also have an individual conversation, just send me an email. I'd be happy to talk to you about details of our specific services. Let's see, how long have you run this service? So I've been running JupyterHub for about 3 years now. Ours, we started in the before 1.0 stage. Right now we're running 2.3.0. Going to move to the 2.3.1 because of a serious bug, or that we find serious, but maybe not important to other people. We have about 3 total people, I would say, that support this. Now, I don't do this full time. I would say it's actually probably 20% of my time to 50% of my time, depending on what sprint is going on. But I have a lot of other duties, including making sure networks and storage and batch schedulers all work as well. But so I would expect it requires less than a full-time admin if you were going to put it in there. We have ours as just more like a bus factor scenario. I'm certainly the principal owner of this project, but we have a couple others that are more than happy to dig in and understand if there's an issue. So.
Well, we really appreciate your time, Jared, and the effort you put in preparing this. We appreciate everybody's attendance for today. We are at the top of the hour. So maybe we will invite you to take Jared up on reaching out to him via email or the Slack channels to pursue additional questions. Again, keep your eye open for announcements for July, kind of for our attempt to do the PERC social, if you're going to be attending PERC. And if not, watch for the announcement for the August session. But with that, we appreciate everybody's attendance and see you next time.
Thank you, everybody.